Hello folks, and welcome to this lesson on the limitations of bond enthalpies. By the end of this lesson, you should be able to explain the limitations behind using bond enthalpies to calculate enthalpy changes of reactions. So let's quickly go over what bond enthalpy is, and while we're doing this, I'm going to talk about a few limitations for why you can't always use bond enthalpies to figure out what the enthalpy of a reaction is. So bond enthalpy in and of itself is referred to as a change when 1 mole of covalent bonds in a gaseous molecule is broken under standard conditions. Because the definition is under the fact that it is broken, that's why you see all of the values in your references showing as positive numbers, because breaking a bond is always going to be endothermic. Now in this particular case, you see a few limitations already. First of all, you have to be only looking at covalent bonds. So if you have ionic bonds involved anywhere in this, it's not really going to work when you're trying to do these calculations. The other part is that we are always looking at gaseous molecules. So that means if any of your reactants or products are not in gas form, if they are in any other form at all, these bond enthalpy values really don't work at all because of the fact that you have other interactions that happen between these molecules when they are in different states. One of the big things to consider for why these would be different is intermolecular forces. When you have a gas, a lot of these gas particles are going to be moving around very quickly, very far apart from each other. By definition, gases take up a lot of space. There's a lot of space between the molecules. Once they get closer together, you also have intermolecular forces coming into play that might affect how much energy is absorbed or released when you're reacting with these substances. Now for the second bullet point, I just wanted to make sure that you remember that when you're breaking versus making bonds, the number that you're going to use, the quantity that you're going to use is going to be the same. You just have a different sign. So whenever you're breaking a bond, it is always going to be endothermic, and when you are making a bond, it is always going to be exothermic. And so basically, when you're using these bond enthalpies to figure out what the enthalpy of the reaction is, you're basically looking at, okay, if I were going to disassemble everything and then put everything back together again, what is the overall change in enthalpy? A third thing for you to keep in mind is that all of your bond enthalpies are going to be average bond enthalpies. So sort of like what I was mentioning with the whole, if it's gaseous, then there are certain things you don't have to worry about. Same thing happens within a molecule itself. Depending on what other things are bonded, what other bonds exist in your molecule, this can also affect the bond enthalpies within a molecule itself. So in one particle, you might have a slightly bigger or slightly smaller, say carbon-carbon single bond enthalpy than a different one. And so because it's an average, it's not going to be particular to your specific molecule or that specific molecule. And so because of that, the values can be further off compared to other values that can be used, like enthalpies of formation and so on and so forth. Now, I wanted to sort of remind you about potential energy profiles and remind you about the fact that activation energy is a thing that exists. I'm not going to talk too much about it right now, but based on what you see in this particular lesson in bond enthalpies, you might be able to figure out why there might always be an activation energy for every single reaction that exists. It's because to be able to perform a reaction, you're going to probably have to break some bonds first before you start making them and ending up with the products that you have. Now, this being said, can you directly calculate activation energy by looking at the bond enthalpies and calculating that? No, you cannot. The reason you can't do this is, one, you still have all those limitations that I just talked about, and two, you're not breaking every single bond in a molecule just to be able to make everything back again. It might only be 1 or 2 bonds that are being affected, And there can be other factors that can increase or decrease that activation energy as well. But I just wanted you to consider, oh, yeah, activation energy is a thing. Probably, maybe it's related to bond enthalpies and things related to that. That's the end of this lesson. I'll see you next time.